Okay, this video is going to show you two different ways to solve this problem. One using the washer method, one using the shell method. We'll set up the definite integrals. I'll post a link to a Desmos graph where you can check your work. Okay, so for the washer method, we want to use the fact that we're going to take pi times the definite integral from, well, in this case, this is the point -1, 1, and this is the point 1, 1. So we're going from this x to this x, and this is a typical washer right here between -1 and 1. So we're going from -1 to 1, and then we have to do outer radius squared minus inner radius squared. Question is, what is the outer radius? Well, again, when we use the washer method, our typical washers are perpendicular to the axis of revolution. The outer radius is the distance from the axis of revolution to the outermost part of the region that we're revolving around that axis. So the y-coordinate of this point right here is x squared, because we're on the parabola. And so the distance from here to here is, well, the y-coordinate of this point is 3, always. So y-coordinate at the top minus y-coordinate at the bottom. There's the outer radius right there, 3 minus x squared. And we've got to square that. Minus the inner radius squared. What's the inner radius? Well, it's the distance from here to this point. Well, the y-coordinate here is always 3. The y-coordinate here is always 1. So it's 3 minus 1, which is 2, squared. There's your setup for the definite integral. I'll leave the work for that to you. For the shell method, we want our typical shells to be parallel to the solution. And we want to take 2 pi times the definite integral. Well, where do these shells occur? They go from this 0 up to this 1. There's another typical shell right there. And then we have to multiply the length of that typical shell, or the height of that typical shell, by the distance from the axis of revolution to that shell. This little distance right here is y. Or we could say that the y-coordinate of this point right here is y, and the distance from here to here is 3 minus y. That's the average radius. And we want to multiply that by the height of the shell. Well, we have to solve y equals x squared for x in terms of y. So x equals plus or minus the square root of y. And so the x coordinate of this point is, for every y, we take the opposite of the square root of y. That's the x coordinate of this point, the x coordinate of this point. For every y, we take the square root of y. And so the height of this shell is the x coordinate at the right minus the x coordinate at the left. So it's the square root of y, minus the negative square root of y. And of course, dy. And just so you can see what this looks like. Oh, by the way, we went from 0 to 1. That's where these typical shells occur. 0 to 1, 3 minus y times square root of y plus the square root of y is 2 square roots of y, you can write is y to the 1/2, distribute, find the antiderivative, etc. Okay, so there's the setup. Post the link to the Desmos graph.